All right, so let's look at some conformers of some other alkanes. In this case, we'll take a look at butane. So butane is going to be 4 carbons long. So 1, 2, 3, 4. Depends kind of low on battery here. And so we can think about taking our eye and looking down this bond right here, right? So we're going to look at this carbon-carbon bond right here. And then, of course, don't forget that there are hydrogens here, right? There's a hydrogen here, hydrogen here, hydrogen here, and then hydrogen here, right? So we can think about what our front carbon looks like and what our back carbon looks like. So in this case, our front carbon is going to have a hydrogen off to the upper left and upper right. And then when we go down, there's going to be a methyl group, right? A CH3. So now you can see this is different than that of ethane because now we've got different substituents on here. And then we've got our carbon in the back. So that's going to be kind of this guy right here. And it's got a hydrogen to the bottom left, bottom right, and then a CH3 group on top. And then, of course, we can rotate about this bond and we can draw other Newman projections. Now, we know that the eclipsed projections are higher in energy, so we're not going to bother to write any of the eclipsed ones because they're higher in energy, so they're not as kind of valuable to us. So what we're going to do is just rotate this back carbon. So there's one conformer. We could draw another conformer, right? We're only rotating the back carbon, so this one will always stay the same. And now we move our CH3 to this position. And then we could continue to rotate it. And these would be the 3 staggered conformers, right? So these are all staggered. And so with ethane, we saw that all the staggered conformers had the same energy, but now we have different substituents. And so now these don't all have the same energy, right? So we can see in this left picture, the biggest groups that we have are these methyl groups, right? A CH3 is bigger than 1H. And we can see here that they're on opposite sides. This is called anti. And in the anti-conformer, the big things or the big groups are as far as possible, right? They're anti to one another, opposite sides. And so this is going to be the lowest energy. And this is because of something called steric strain. Steric strain just basically means that big things don't want to be next to each other because they're big and you'd have to squish them together. And so to reduce steric strain, you want the big things as far as possible. So in this anti-position, the big things are as far as possible. Whereas if we take a look on these two on the right here, we can see that these big things are somewhat close to one another, right? They're still staggered, but they're next to each other. This conformer is called gauche. Gauche. And in gauche, the big things or the big groups are next to each other. And this results in a higher energy state. This is not the highest energy. The highest energy would be these two methyl groups actually eclipsed with one another, right? So it's still better than eclipsed, but anti is the best, right? And again, steric strain is really just because they're big things, right? So we have a CH3 over here, and then we have a CH3 over here, and steric strain is this right here, right? They're all really big, and so they're kind of crashing into one another. They'd prefer to be further away, so they'd prefer to rotate about this bond. And now they're as far as possible, right? This one's anti and lower in energy. So just get some practice looking down these bonds and trying to predict what would maybe be the highest or lowest energy conformer.